In question 3, we have a roller coaster train being accelerated by being pulled horizontally by a cable. In A, we're told it accelerates from rest to 58 meters per second in 3.5 seconds, and the mass is 5,800 kilograms. In part 1, we need to find the average acceleration of the train. Well, for that we can use v equals u plus at, rearranging for the acceleration a, putting in the values, gives 17 meters per second squared. In part 2, we need to find the average tension in the cable as the train is accelerated. Well, for this, force equals mass times acceleration, putting in the values, gives 96 kilonewtons. In part 3, we need to find the distance the train moves while accelerating from rest to 58 meters per second. Well, for this we can use s equals ut plus a half at squared. This simplifies as u, the initial velocity, is 0. We put in the values and we get a distance of 100 meters. In part 4, the efficiency of the roller coaster acceleration system is just 20%. We need to find the average power input to the system during the acceleration. Well, work done equals force times distance moved in the direction of the force. So power is work done over time taken. Combining these gives the power as force times distance over the time taken. We have a force of 96,000 newtons over 100 meters in 3.5 seconds, giving a power output of 2.74 times 10 to the 6 watts. But the system is only 20% efficient, so the input power must be 5 times this. This comes out at 1.37 times 10 to the 7 watts, or 14 megawatts. In B, after reaching its top speed, the driving force is removed and the train begins to ascend a steep track. By considering energy transfers, we need to find the height that the train would reach if there were no energy losses due to friction. Well, here the kinetic energy will be converted into gravitational potential energy. Kinetic energy is mv squared over 2, gravitational potential energy mg delta h. So the m's cancel and we can rearrange as the height gained will be v squared over 2g. Putting in the values gives a height of 170 meters.